Welcome back, everyone. We've done a lot of discussion on supervised learning methods, as well as evaluating the performance of supervised learning, such as regression tasks or classification tasks. Now, let's go ahead and finally discuss unsupervised learning. So, recall that when we're dealing with supervised learning, the actual label was known due to historical labeled data. For example, with those images of dogs and cats, we actually had historical information where someone manually went in and labeled images as dogs and cats. And then, upon model deployment, we could see a new image and predict if it's a dog or a cat. But what actually happens when we don't have historical labels? For example, we just have all those images, but no one's gone ahead and actually labeled them dogs versus cats. We just have the raw image files. Or we just have raw data in general that doesn't have any sort of label. This is unsupervised learning. And there are certain tasks that fall under this umbrella of supervised learning. There's tasks like clustering, anomaly detection, and dimensionality reduction. Let's talk about these individually. Clustering is when we're trying to group together unlabeled data points into categories or clusters. And then data points are assigned to a cluster based on their similarity to other points within that cluster. So if we only had those images, what we could attempt to do is cluster them together into two groups. And then we could end up seeing, hey, we have a cluster here that's similar to each other and another cluster that's similar to each other. But keep in mind, since this is unsupervised data, we technically could end up with an approach that doesn't actually correspond with the labels we had in our minds beforehand. For example, if we specified we wanted to cluster together these images into two main clusters, we could accidentally end up clustering large dogs and large cats in one image cluster, and then small dogs and small cats in another image cluster. So what's going to happen is your machine learning model is going to attempt to cluster together based off similarity. And you're not always guaranteed a correct result because remember, you didn't have the label to begin with, so there's technically kind of no right answer, which makes actually evaluating these models' performance a lot more nuanced. Now then there's also anomaly detection, which attempts to detect outliers in a dataset. For example, fraudulent transactions on a credit card would be anomalies, and we would like to detect those. And technically, often you're not going to have historical labels of fraudulent transactions because they're so rare to occur. So really what we're looking for here are points that are really dissimilar from everything else in the dataset. And that also falls often under unsupervised learning because you don't have that historical label of fraudulent transactions. And then there's also dimensionality reduction. And dimensionality reduction are data processing techniques that reduce the number of features in a dataset, either for the purposes of compression or to just better understand underlying trends within a dataset. So in unsupervised learning, the most important thing to note here is that these are situations where we do not know and do not have a correct answer for this historical data. We don't have that label, which means evaluation is much harder and more nuanced because there's technically no correct answer to actually compare to. So you're not going to get things like accuracy, precision, or root mean squared error because technically there's no correct answer to actually compare this to. If you had that label to begin with, then you would have just done supervised learning. So that's what makes unsupervised learning not necessarily harder, but just the evaluation of it is a lot harder. And keep in mind, for an unsupervised process, we no longer have that test-train split since we don't have that right answer to compare with on the test data. So we end up just acquiring the data, cleaning the data, and then we're going to train or fit our model on all the data, and then afterwards perform some sort of transformation on that data set, such as that dimensionality reduction. And then once we do that, we can deploy the model. But again, we don't have that correct answer to compare to, so we're not really able to do any sort of comparison to a test set when it comes to an unsupervised learning process. Now later on in this course, we're going to explore unsupervised learning processes with specialized neural network structures, such as autoencoders. But for the first major chunk of the course, we're really going to focus on supervised learning, and then later on we'll come back to unsupervised learning. All right, thanks, and I'll see you at the next lecture.